This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on angular speed and linear speed. Our question here says a bicycle wheel has a radius of 10 inches and it is spinning at a rate of 50 revolutions per minute. What is the angular speed? Now, angular speed is radians per unit time, so we're having minutes here. We're going to look for radians per minute. So currently we have 50 revolutions per minute. How do we convert revolutions per minute to radians per minute? One revolution, of course, is 2 pi radians. So knowing that, how can we go ahead and do that algebra? 50 revolutions per minute times 2 pi radians per revolution. Revolutions cancel. 50 times 2 pi is 100 pi. What am I left with? Radians per minute. That is the angular speed. The angular speed is 100 pi radians per minute. So we use this notation for angular speed. This little omega looks kind of like a W, is the angle in radians divided by the elapsed time, which is what we did in the previous example. So that's relatively straightforward. Now, linear speed, how many miles per hour, or in this case, inches per minute, is this thing traveling? So we know that speed is distance divided by time. So we'll say that this speed is s divided by t. Can we figure that out? Well, to answer that question, 50 revolutions per minute, we need to figure out what distance that will be. So 50 revolutions is what distance? 1 revolution is what distance? 1 revolution on a bicycle wheel is going to correspond to 1 circumference. So we recognize that idea, and the circumference of a circle is 2 pi times the radius. So in this case, 1 circumference is going to be 2 pi times 10 inches. 2 pi times 10, or 20 pi inches, will be 1 revolution. So we get that circumference is 2 pi times the radius, 2 pi times 10 inches. 20 pi inches is our circumference. 1 revolution is 20 pi inches. But what are we saying? We're saying we have 50 revolutions per minute. We want to convert that to inches per minute. That will give us our linear speed. So 50 revolutions per 1 minute times 20 pi inches per revolution. This is our circumference. Multiplying that together, 50 times 20 is 1,000 pi. Revolutions cancel, and we get inches per minute. That is our linear speed. So what are our rules here? What's our notation? How do we put all this together? What do we know? We have our angular speed is theta divided by t, number of radians divided by time. Our linear speed is what? We said our linear speed is distance divided by time. Now how can we equate these two ideas? Well, what is s? S is the distance traveled. It is equivalent in a sense to the arc length of a sector. So how far do we travel if we have a certain number of radians and we know the radius? How far have we traveled? What is the arc length of that sector? What do we know? So we recall what we have to do. We've got to take the total angle theta divided by the entire number of radians for the circle. So it's theta divided by 2 pi. That's our fraction of the circle times the circumference. That will give us the arc length of that sector. So again, theta divided by 2 pi, we're starting with a piece of a circle. Theta is that amount of radians we have divided by 2 pi, radians for the entire circle, times the circumference for the entire circle. And of course, the circumference of a circle is 2 pi r. So that we multiply those together, what do we get? We just get r theta, and you may recognize that for a sector, the arc length is r theta. Now when we do this, we perceive that theta is less than 2 pi, but there's really no reason we have to do that. Because if we're thinking about a wheel rolling, if we have 2 pi, 4 pi, 17 pi, that same strategy is going to work. We just take that total angle that we've moved through times the radius to give us our arc length, or our distance traveled. So if I replace the s with r theta, how is that going to work for us? What will v be in that case? So indeed, v is s over t, and s is r theta. So now we have v is r theta over t. But now we have to ask ourselves, what's theta? You can see up here, if we solve for theta, multiplying both sides by t, omega times t is theta. So making that substitution, again, solving for theta, omega times t is theta. Now we get the linear speed is r times omega times t divided by t, which of course will give us our shortcut rule that the linear speed is just the radius times the angular speed. So that's helpful for us at times as we're looking at this. So let's take a look at one more question. Child is spinning a rock at the end of a 3-foot rope at the rate of 100 revolutions per minute. We want to find the angular speed of the rock, and then we want to find the linear speed of the rock when it is released. Angular speed of the rock, what's our theta divided by distance? So we have 100 revolutions per minute. How do we convert that into angular speed? 100 revolutions per minute, fine. We know we have 2 pi radians per revolution. So now revolutions cancel, and we're left with radians per minute. 200 pi radians per minute is our angular speed. Now we had our shortcut for linear speed. So once we get radians per minute, if I want to get linear speed, all I have to do is multiply that omega times the radius. So the linear speed v is the radius times omega, 3 times 200 pi, 600 pi feet per minute. So that's a technique that you're going to use in physics courses. Frankly, I prefer doing it the long way. So let's do the linear speed one more time, thinking about what it means. So linear speed of the rock when it is released. I have 100 revolutions per minute. Well, 1 revolution is how many inches, or how many feet, I guess is our unit here. 1 revolution is how many feet? Well, it's a 3-foot rope. 1 revolution corresponds to 1 circumference. The circumference is 2 pi times the radius. 2 pi times 3 feet will be 6 pi feet. 6 pi feet is our circumference. 6 pi feet corresponds to 1 revolution. So indeed we get this. So circumference is one way around that circle. So our circumference is 6 pi feet. That corresponds to 1 revolution. Then all I have to do is convert 100 revolutions per minute into feet per minute by using this substitution. So how does that going to look? 100 revolutions per minute times 6 pi feet per revolution. We'll notice revolutions cancel. The units we're left with are feet per minute. 100 times 6 pi is 600 pi feet per minute. And you'll notice that this agrees with the answer that we had earlier. When we looked at this before, what did we see? The linear speed v was just the radius times the angular speed. 3 times 200 pi was 600 pi feet per minute. So we did it 2 different ways and have the same result. And that will conclude this lesson.